In this question, we want to find the maximum area of a rectangular field whose perimeter is 600. So two things that I have as my variable. I'll use W is equal to the width, and L is equal to the length. So when I have a rectangle, I have width, width, length, and length. So first thing that I know is my isolating equation is the one with the answer. So the perimeter is 600. So if we look at the perimeter, it's the distance all the way around. So I need a width, a length, a width, and another length. So altogether I need 2 widths and 2 lengths, which will equal to 600. Now I notice that each of these numbers is divisible by 2, so I'm going to divide each one by 2 to end up with width plus length equals 300. Now let's look at my max-min equation. I'm looking at a maximum area. So my substituting equation is going to be max is equal to length times width. Now remember, in this equation you're only allowed one variable, so I need to go back up to my isolating equation and isolate for one of my variables. So I will subtract width from both sides, and I end up with length is 300 minus W. It doesn't matter which one you isolate for. So since I have a new expression for length, instead of using length, I'm going to use 300 minus width in this equation to figure out what my maximum area is. So maximum area is going to be length, 300 minus W, multiplied by width, which is W. Now I'll apply my distributive property, and I get 300W minus W squared. Or, just rearranging it with my W squared first, I'll have negative W squared plus 300W. So that is the equation that I want to complete my square for. So looking at this, I have negative W squared plus 300W, and I want to complete the square for this. First thing I'm going to do is factor out a negative 1. So I'll have W squared minus 300W, and that's what I'm going to complete the square for. So W squared goes here. I take negative 300W and I divide it into 2 equal pieces. And I know that this is going to factor as W, negative 150, W, and negative 150. And I always want to check just to see if I did that right. So what I'm going to do is W times W, W squared, negative 150 times W, negative 150W, W times negative 150, negative 150W. So what will complete the square is negative 150 times negative 150, or 22,500. So let's go down here, and inside the brackets I am going to add 22,500 and also subtract 22,500. Nothing outside my brackets. Now I know that this is okay because 22,500 take away 22,500 is really 0, and I can add 0 to any equation without changing its value. So now let's look at my perfect square trinomial, which is right here. And I know from my grid that that factors as W minus 150 times W minus 150. So I'll just write that out as negative 1 times W minus 150 all squared. Now what goes outside the brackets, since I have a number in front of the brackets, is negative 1 times negative 22,500. And negative 1 times negative 22,500 is positive 22,500. So let's state my vertex. My vertex is opposite of the inside, 150, and 22,500 on the outside. Now since my leading coefficient is negative, I know that I have a parabola that opens down, which means I have a max. So remember, this is what tells me what my max is. This tells me when my max occurs. So in the context of this question, 22,500 is my maximum area. Now go up here and I'm talking about meters. So 22,500 meters squared is the max area. And when that occurs, well, we had all these W's here. So it occurs when the width is 150 meters. Now, if that's what the width is, let's go and figure out what the length is. So go to my isolating equation, and the length is 300 minus the width, which we just found was 150. So the length is also 150. So it's a square. So the length is 150 meters. Let me just put this as a big screen here, and I want to check to make sure I answered the question. It says, what is the maximum area? So the maximum area is right there. It didn't ask for the dimensions, but in case it did, that's how you find them.
You're doing